Hi guys, we're going to continue talking about volume. In this lesson, we're going to talk about volume of a cone and volume of a sphere. So volume of a cone is a three-dimensional figure with one circular base that's connected by a curved surface to a single vertex. So our base shape with a cone is a circle, and then it's coming to a point. So this, the formula to find the volume of a cone relates to finding the volume of a cylinder. Remember how when we had a cylinder, our base shape was a circle? We had a circle at the top and we had a circle at the bottom. So what we did is we found the area of the base of this circle and we multiplied it by the height. Well, if you look at a cone, it looks just like a cylinder, but it's just a piece of that cylinder. Notice how I drew the cylinder going around this cone. And it splits this cylinder up into three sections. You have 1, 2, and 3. The second section right here is the cone that we're trying to find the volume of. It's 1/3 of the cylinder. So that is the formula that we are actually going to use. The volume of a cone is 1/3 of the area of the base. So again, if we find the area of that circle, which is pi r squared, times the height of the shape, just like in the cylinder, then I'm going to take 1/3 of that because I'm just taking a portion of that cylinder, 1/3 of that. The one thing you have to be careful of is the height when you're dealing with a cone is the part that goes from the center of the base, the center of that circle, right up through the middle of the cone. Okay? This formula not only works for a cone, that's what we're going to focus on this year, but also if we were talking about like a rectangular pyramid, so where the base shape was a rectangle, the same formula would apply. When we were trying to find a rectangular prism, we did length times width times height. Well, our pyramid is 1/3 of that prism. So we could do 1/3 times the length times the width times the height. 1/3 times the area of the base times the height. If you had let's say a triangular pyramid, so the base shape is a triangle, you could find the volume of this, again, 1/3 times the area of the base. So the base is a triangle, so we would do 1/2 base times height of that base shape, and then times the height of the figure. So this formula, 1/3 times the base shape times the height, would work for any sort of pyramid or cone, depending on what that base shape is. All right, let's look at a couple of examples. All right, first one, it says to find the volume of the cone, show the formula, substitutions, round to the nearest hundredth, and label your answer. So these are the same steps that we were doing in the last lesson. Always, step 1, write your formula. Step 2, show the substitution. Step 3, we're going to round our answer and label our answer. Same 3 steps whenever we're using a formula. All right, so I look at my shape and it's a cone. So when I think, okay, I want to find the volume of a cone, I'm going to write down my formula. 1/3 pi r squared times the height. Okay, what do I need to pull out of my diagram and put in the formula? My radius and my height. So when I look at my diagram, I know the radius is the dimension that goes from the center of the circle to the outside of the circle. So the radius is 3. I know my height goes from the middle of the base straight up to the top of my cone. So the height of this shape is 6 inches. So now that I know my radius and my height, I'm going to plug those into the formula. So 1/3 pi 3 squared times 6. All right, so this particular problem says round to the nearest hundredth. So at this point, I'm going to plug all of this into my calculator. And notice how when I did my substitution, I wrote pi, because remember, this year we are using the pi key. Do not put 3.14. You are going to use the pi key whenever we are dealing with circles this year. So now I'm going to pick up my calculator. I'm going to put 1/3 into the calculator. I'm going to hit my pi key, 3 squared times 6. And you can type all of this into your calculator as long as you type it in exactly how it is written. So when I put that into the calculator, I end up getting 56.5486677, and then it keeps going. All right, the directions say round to the nearest hundredth. So the nearest hundredth is 2 decimal places. So I'm going to look at the digit to the right of the hundredth place. And since it's 5 or higher, it's going to bump this up to the next digit. So the volume of this shape is 56 and 55 hundredths. And then I'm going to label it inches cubed. All right. Let's look at the next one. This one, the directions are saying to write your answer in terms of pi. So this time, I'm going to go through all the same steps as I did in the previous example, but I am going to leave it in terms of pi. So I am not going to hit that pi key when I input all my information into the calculator. All right, so let's go through our steps. Step 1, write the formula. V equals 1/3 pi r squared h. Now I'm going to substitute in what I know. 1/3 pi 2 squared, because that's 2 is the radius, times the height. Now I'm going to put in the calculator. When I put this in the calculator, I'm leaving it in terms of pi. So I'm going to type in 1/3 2 squared times 7. When I put in 2 squared times 7, I end up getting 9 1/3. So I can write 9 1/3 pi, and then I can label this feet cubed. And that would be the volume in terms of pi. All right, next example. Word problem. It says a cone-shaped paper cup is filled with water. The height of the cup is 10 centimeters and the diameter is 8 centimeters. What is the volume of the paper cup round to the nearest hundredth? So whenever I have a word problem, I am going to draw a diagram. So it says that the cone-shaped paper cup. So I know I'm talking about a cone. So I'm going to draw my cone. All right, it says that the height of the cup is 10 centimeters. So when I'm talking about this cup, I'm talking about this cone, I know the height is going from the center of my cone up to the point, and that is 10 centimeters. And the diameter is 8 centimeters. So diameter, I know, goes all the way across the circle or the base. So 8 centimeters. What is the volume of the paper cup? All right, so I have a cone here. I remember that the formula for volume of cone is V equals 1/3 pi r squared h. All right, so I'm going to plug in what I know. So I have 1/3 pi. Well, now I get to radius. I don't know my radius. But what I do know is my diameter. And I remember from last year that radius is half of the diameter. So I'm going to take my diameter, which is 8, and I'm going to divide it by 2. And when I do that, I get my radius of 4. Now that I know my radius, I'm going to plug that in, and then I'm going to plug in my height of 10 centimeters. All right, this says round to the nearest hundredth. I can put this whole entire thing into my calculator. So I'm going to type in 1/3, so that 1, AB/C, 3. I'm going to hit the pi key, times 4 squared, times 10, and hit enter. And when I do that, I end up getting 167.551608, and then it keeps going. This says to round to the nearest hundredth. So I'm going to look at the decimal point to the right of that, or the number to the right of that. And since it's less than 5, the hundredth place is going to stay at 5. So the volume of this cup is 167.55 centimeters cubed. And the only thing I'm going to change in my answer, I'm going to erase this equal sign. Because I rounded, remember, it's now an approximation. All right, our next shape is the volume of a sphere. So remember, a sphere is a ball. All right, a sphere is a set of all points in space that are a given distance known as the radius from a given point. So when you're talking about a ball, you have the middle of your ball. When it's talking about this given distance from the center, it's because every part of the ball is the same distance from the center of your sphere. Okay, that's what makes it a sphere. Some of the real life scenarios when you're thinking about a sphere, think about like a baseball, think about a basketball, soccer ball, any sort of ball. Think about a scoop of ice cream. Think about the moon. Think about a beach ball, anything that's round. And that's talking about a sphere. Okay. All right, looking at our little Venn diagram here, we're describing the different parts of our sphere. It says, describe the cross-section of the sphere. All right, when we're looking at the cross-section of the sphere, what it's talking about is this circle that's going from one side to the other. All right, this would also be a cross-section of your sphere. You have that circle that's going from one side to the other. You still have a center point, and you still have the radius from the middle to the outside of that sphere. Okay, you can do that in any section of your sphere. Here is that cross section. You have that circle that's going through or running the outside of the sphere. You have the middle section. You have the center of the sphere that goes to the outside of the circle. All right, name its parts of the sphere. I already talked about this. Radius, going from the middle of your sphere directly out to the outside of the sphere. And I talked about these two. The center is right in the middle of your sphere, and examples, we named a couple up here. All right, volume formula of a sphere. The volume formula is always going to be 4/3 pi r cubed. So this time we're not multiplying anything by the height because we don't really have a height of a sphere. right? You have that radius that keeps going out and out and out and out and out. It's that same dimension that you're multiplying by itself 3 times. That's what makes it three-dimensional. Okay, so you're going to cube it, multiply it by pi, and then by 4/3. Again, because you're dealing with a circle, you may be asked to find the volume in terms of pi, or you may be asked to solve and round it. So the first example, we have our ball. Step 1, again, I'm going to write that formula. All right, 4/3 pi r cubed. And I'm going to plug in what I know. Well, 4/3 and pi are standard in the formula. My radius going from the center of my ball to the outside is 3, and I'm going to cube that. Since it says to write it in terms of pi, the only thing that I'm going to put in the calculator is the 4/3 times 3 cubed. That's the only part I'm going to put in the calculator. Then I'm going to hit enter. And in this case, 36 comes up. Since I'm leaving it in terms of pi, pi will be in my answer. So 36 pi millimeters cubed will be the answer. All right, let's do another example. I have another sphere, and I remember that my formula is 4/3 pi r cubed. So I'm going to plug in what I know, 4/3. Now, I'm given the diameter of 18. So I know to find my radius, I have to take 18 and divide it by 2. So my radius will be 9. So I'm going to do 9 cubed. Now, I can put this right in the calculator. And 4/3, since it's in terms of pi, I'm going to put 4/3 times 9 cubed in the calculator. And I end up with 972. Pi will be in my answer because it's in terms of pi, centimeters cubed. And that would be my volume. All right, here's an example of where you round to the nearest hundredth. So this time you will be hitting the pi key. All right, it's a sphere. So I'm going to follow the same steps. I'm going to write my formula, 4/3 pi r cubed. I'm going to put 4/3 in the calculator. I'm going to hit the pi key. I'm going to substitute in 5 for my radius. So I'm going to put 5 in the calculator and then cube it and hit enter. And then I'm going to get 523.598775 ... It keeps going. It says round to the nearest hundredth. So if I look at the hundredths place and I look at the digit to the right of it, it's going to bump it up. So this is going to bump up to 523.60. And yes, this goes up to a 0. But since the directions say round to the nearest hundredth, I have to put that 0. I have to go all the way out to the hundredths place. Inches cubed. Okay. All right. Try the next one on your own. Recognize that this is the diameter that you are given. So think about what you need to do before you can do any substitution.